Okay, let's dive right into this. Picture it. June 30th, 1908. It's a typical quiet morning over the remote Siberian forests. Just a few local villagers and hunters out and about. But in a literal flash, that peace was violently shattered by an event so incredibly massive and honestly so baffling that well over a century later, we are still trying to unravel its secrets. Welcome to today's Explainer. We're going to dig into the data, the historical records, and the hard science behind the massive blast famously known as the Tunguska Explosion.
To truly grasp the sheer scale of this thing, we really have to look at the immediate aftermath. The blast that morning was so unbelievably powerful, it literally threw people to the ground who were standing over 60 kilometers away from the epicenter. Just think about that for a second. Imagine being dozens of miles away from an explosion and still getting violently knocked off your feet by the sheer force of the shockwave. And it didn't stop there. Windows shattered in homes hundreds of kilometers away. The atmosphere was so profoundly disturbed that the night sky glowed for days. Actually, historical reports even say that folks all the way in London could read their midnight newspapers just by the light of the glowing sky. Now, the impact on the landscape itself was even more staggering. We're talking nearly 80 million trees, completely flattened. And this wasn't just a small patch of woods. This absolute devastation spanned across more than 2,000 square kilometers of Siberian forest. To put that into perspective, when you map it out from above, the pattern of the fallen trees actually forms this massive butterfly shape. Researchers estimate the force of the Tunguska event was hundreds of times stronger than the atomic bomb dropped on Hiroshima. It was an entire ecosystem instantly laid to waste, snapping these massive trees like they were just tiny twigs. Which brings us to the ultimate whodunit of the natural world. What exactly flattened 80 million trees with the force of a modern nuclear weapon, but didn't leave a crater? There was no bomb dropped, right? No volcanic eruption anywhere near the area. And shockingly, despite all that unbelievable damage on the ground, there was absolutely no known explanation and absolutely no impact crater to be found. It's like the culprit just vanished into thin air. Section 1, the impossible crime scene, the 1927 expedition. Now, what's really interesting here is how we actually started piecing this giant puzzle together. Around 7:15 that morning, witnesses reported seeing this brilliant blue-white object racing across the sky. They said it was even brighter than the sun right before a gigantic fireball exploded above the forest. But because this part of Siberia was incredibly remote, it actually took nearly 2 decades for scientists to finally trek out to this impossible crime scene. When the expedition finally arrived in 1927, they had a very clear expectation. They were fully expecting to find a massive impact crater. But instead, they were met with a totally bizarre reality. They found trees lying completely flat, pointing outward in every direction. But inexplicably, right at the very center of the destruction, some trees were still standing. They were totally burned and stripped of their branches, but standing perfectly upright. Scientists now call this eerie phenomenon the telegraph pole effect. And even more baffling, after scouring the entire area, they didn't find a single large meteorite fragment. No way. It's a question that haunted those early investigators, and it honestly continues to echo through history. Where was the crater? I mean, if a giant rock from space hits the Earth hard enough to level 2,000 square kilometers of forest, there absolutely should be a massive hole in the ground. That complete absence of a crater took an already incredible event and turned it into this profound scientific mystery. Section 2. Asteroids, Aliens, and Tesla. The search for a suspect. Because the evidence on the ground was so unusual, a lot of people completely rejected the leading scientific theories at the time, which pointed to an icy comet or large asteroid. That lack of physical evidence, namely no crater and no large space rocks, sparked an absolute frenzy of debate. You know how it is? When the physical evidence doesn't match our traditional understanding of how the world works, people start looking for alternative suspects. Over the years, some much stranger, totally unproven theories started popping up. Some folks suggested it was an alien spacecraft crashing to Earth. Others hypothesized it was a secret military experiment, or even a tiny black hole passing straight through our planet. Some even pointed the finger at the inventor Nikola Tesla, suggesting his wireless energy experiments had gone horribly wrong. It turns out, when the math doesn't immediately add up, humanity is completely prepared to blame a brilliant inventor or a stray black hole just to make sense of the universe. Now, while none of these fringe ideas has ever been proven, they really highlight just how desperately people wanted to solve this puzzle. Section 3. The modern scientific consensus. Solving the mystery.
Today, after well over a century of research, data modeling, and analyzing the physics of impact events, most scientists actually agree on a specific verdict for this century-old crime scene. But to understand this consensus, we really need to define a specific term: airburst. So an airburst is an explosion that occurs high up in the atmosphere. It happens when extreme atmospheric pressure causes an object, like a meteor, to detonate midair, long before it ever actually makes physical contact with the ground. But listen, it's not just a simple pop. It is a massive transfer of physics. The immense kinetic energy of the object traveling at tens of thousands of miles per hour is instantaneously converted into thermal energy, causing a truly catastrophic explosion right there in the sky. And this is the exact mechanism that scientists agree caused the Tunguska event.
Let's break down the mechanics of how this works, step by step. And this brilliantly illustrates the missing puzzle piece, exactly why there was no crater. Step 1. An asteroid, roughly 50 to 60 meters wide, enters Earth's atmosphere at an absolutely incredible speed. Step 2. As it plows through the air, the atmospheric pressure in front of the asteroid builds up immensely. The rock simply cannot withstand the stress. Step 3. The asteroid violently explodes mid-air, reaching its terminal altitude about 5 to 10 kilometers above the Earth's surface. And finally, Step 4. This massive, high-altitude explosion generates a devastating shockwave that travels down to the ground, flattening the forest outward into that distinct butterfly shape, but leaving the trees directly beneath the blast, standing upright as those stripped telegraph poles we talked about. And crucially, because the rock essentially vaporized 5 to 10 kilometers up in the sky, it left absolutely no crater behind. Now, the airburst theory is incredibly elegant, and it explains almost the entire crime scene. However, questions do still remain. If a 50 to 60 meter rock exploded above the Earth, why were so few fragments ever discovered by researchers on the ground? Today, modern researchers look for microscopic evidence, things like tiny spherules of melted rock or specific isotopic signatures hidden deep within the Siberian peat bogs. So while the airburst perfectly explains the lack of a crater and the pattern of the fallen trees, scientists still debate if every single tiny detail of that morning in 1908 has been completely explained.
Section 4, could it happen again? The ongoing threat. Which brings us to an absolutely crucial point: why understanding Tunguska matters to us today. This isn't just some historical curiosity or a fun puzzle for physicists to solve. It's a stark reminder of the environment our planet exists within. By studying the mechanics of the 1908 explosion, we're actually studying a very real, ongoing threat to our modern world. The Tunguska explosion holds a pretty sobering title. It remains the largest impact event in recorded human history. And it is vital to take away this one fact: if an identical 50 to 60 meter asteroid were to experience an airburst over a modern, heavily populated city today, the destruction would be unimaginable. Millions of lives could be lost in a matter of seconds. The exact same energy that flattened 80 million trees would easily level skyscrapers and infrastructure across a massive metropolitan area. And to make that threat feel truly visceral, we only have to look back to 2013 when the Chelyabinsk meteor, which was a much smaller rock, by the way, exploded over Russia, shattering windows and injuring over 1,000 people. It's a very real reminder that this is an ongoing reality, not just ancient history.
This leaves us with a pretty chilling reality. First, our planet is still highly vulnerable to objects from space. Space is crowded with debris, and our orbit crosses paths with these objects way more often than we'd like to think. Because of this, scientists around the globe are constantly monitoring the skies, aggressively mapping near-Earth objects, calculating trajectories, and upgrading our planetary defense systems to track smaller and smaller threats. But despite all our best technology and constant vigilance, the most terrifying point is that last one. The next Tunguska-level event could arrive completely without warning, hurtling right out of the glare of the sun before we even know it's there.
So we end our explainer today by looking back at that quiet morning in 1908. Was the Tunguska explosion simply a terrifyingly powerful natural disaster, just a perfect storm of cosmic physics? Or, given the lack of larger fragments and the sheer mystery of the whole shebang, is there still something we're missing? I'd love to hear your thoughts, so please leave your own theories in the comments below. And hey, if you enjoyed this deep dive with me, make sure to subscribe to Artifacts Documentary for more explainers on real mysteries, unexplained events, and dark history. Keep learning, and I'll see you in the next one.